Hello everybody, and welcome to this new episode of our series. Today we're going to talk about infrastructure and security. We're not going to just talk about where the cloud is in terms of security by design, but we're talking about the process and strategy during the migration and adapting the security you have in place in your shared hosting, dedicated hosting, or virtual hosting while migrating to the cloud. So welcome again. My name is Matteo Castellani. I'm a Cloud Solution Architect here at IONOS UK. So the background and the reason why you need to move to the cloud can be numerous, and we discussed some of those in the previous episode of this series. But for sure, one of the most important aspects of your transition to cloud has to be security, which in cloud in particularly is strictly tied to the way you build your infrastructure. So tightly, in fact, that we need to be clear about what to do and what absolutely not to do. And one real important thing that we have to discuss is why the thing not to do is the lift and shift strategy. Now, what is the lift and shift strategy? Usually, when you're migrating your workload from somewhere to somewhere else, you try to just take your workload as it is and just put it on the other infrastructure and try to run it as smoothly as possible. Now, lift and shift during the adoption of cloud has been recognized as an anti-pattern. Anti-pattern is something that sounds like a really good idea and lots of people try to do, but it's got an anti-pattern because it brings more problems and success stories to the table. And especially when we're talking about lift and shift to the cloud being such a different platform from a virtualized platform or a dedicated platforms, it almost always ends up in some kind of problem, and is always recommended to look at your infrastructure and try to rework it as much as possible. Security and secure access to your platform must be adapted to the cloud platform. They cannot just be moved to the cloud platform. Now, to understand why the lift and shift is not a good idea, or what is the right way of doing the migration into the cloud from the security point of view, I just want to bring you through what is the normal journey that a customer gets since it starts with shared hosting, and then how does normally finishes up in the cloud platform. Let's start with the shared hosting. So coming from shared hosting perspective, it's kind of a scary thing to move to a different platform, because in shared hosting, everything from the security point of view is already taken care of. The firewall is set up by the hosting provider. The hardware is secure from the service provider as well. In the case of hardware failure, they do think about everything: the platform security, the data center, the networking. Everything is taken care of, and the only thing that you left to look after is the application security. So making sure that your application cannot be exploited by someone trying to send a little bit too many email through that contact form, or a cross-site attack doesn't work because you secure all the variables. And this is absolutely great. The underlying problem is, though, that the shared hosting does have a little flexibility on it. It just doesn't provide you, if you want to develop your application, or if you want to create services that are helping your application to grow, or your e-commerce to grow, or even if you need to serve more customer than the shared hosting is made for. You may find yourself in a very strange position where you will have to migrate into a more dedicated or virtual service, but you do not really have those capabilities, because when you migrate to one of those services, you're moving from a place where everything is taken care of in a place where nothing is being taken care of, and you will have to upskill or hire someone to help you do this. You will have to take care of the firewall to protect your machine. You will have to put in place a strategy that covers in case of hardware failure. So do you get only one service? Do you get two? Do you build them redundantly? How do you secure your platform? How you make sure that nobody else apart from you has access to the backend? How do you make sure that the networking in between the two machines is connected correctly, that they can talk to each other? And on top of that, you still have to deploy your application and develop your application. But even if you can manage all of this, you will soon realize that there is another issue you need to be prepared for, the scalability of the platform. In dedicated or virtualization, you scale using more than one server to host your website or multiple websites. But because you may buy this service at different time or from different providers sometimes, you can be 100% sure that wide security for a single server will be quite easy to achieve. Security at scale will come at a higher cost, because when you buy more than one server, you're talking about, let's remind ourselves that we're talking about individual public-facing single IP address servers, where the work of securing and connecting and protecting needs to be done manually. Their servers may be completely different one from the other. They may have a different version of operating system. They may have a different firewall version. They may have a different application to run into it. And it's simply just not possible to have a simple standardized way to address all the security needs. You will have just to do everything manually. But then why I'm talking to you about cloud? I mean, cloud is why it should be better. Is at the end is just a glorified virtual server platform, isn't it? Well, no, it isn't. Otherwise, I wouldn't be here talking to you. And for who has been following my webinars, you will know that what I'm going to talk next about is automation. Is a simple thing that improves the way the virtualization is created, virtualization is working, and from virtualized servers becomes cloud. A cloud server is immediately available to you after a few minutes since you click on the button create cloud server, because of the automation, because all the process that were put in place just for you to have a server built fresh, if you allow me to say that. And the same way, you can destroy immediately a server because of automation. And it's why we can bill you by the minute rather than by the month. A cloud server, from the security point of view, can have a firewall configured before it actually gets created because of automation. An entire infrastructure can be protected even if you do not set up a specific machine as a firewall in front of it, again, because of the automation that is in place in the cloud. And there are many of these examples that we're going to do during the time that we have available today. But before we actually get into the how to do it in cloud, let's see a little bit what happened before the cloud. What are the most common mistakes that you see, though the most common infrastructure that I came across for our customer that wants to migrate into cloud, or the most common scenario of people that decide to migrate into cloud because they hit a big limit or they hit a big problem. The first scenario is represented by two different dedicated servers or virtual servers. They both have a public IP address, and we try to load balance those two using a geo load balancer. Now, there are few of our partners that provide this kind of service, and this was never meant to be an aligned service for live, for two servers live, for two infrastructures live. The geo load balancer is usually created to create geo redundancy. So if one infrastructure is down, all the traffic can be reverted to a different infrastructure. And the main reason because it should be used as an emergency system, not as a production system, is the fact that both web servers and geoload balancer are constantly working through the public network. And while this doesn't really make a much difference if you working with the provider that doesn't charge you the egress or the ingress bandwidth, you will have to understand that while the geoload balancer will produce egress bandwidth towards the web servers, at the same time, the web servers will produce egress bandwidth going towards the geoload balancer or going towards the client itself, the requested page. This, in the worst case scenario, will bring you to a double bill where the same amount of traffic gets billed from the geoload balancer to the web server and to the web servers to the geoload balancer, literally doubling your bill. But we're talking about security, right? So this is not the only thing that you need to be careful with. When you're using two standalone servers, you have to remember that those servers do have a public IP address. And having a public IP address, it doesn't matter how much firewall you put into place inside the web servers themselves, you still susceptible of DDoS attack, because the idea of a DDoS is not creating traffic against your web service, is about creating traffic your web service. The fact that no connection can actually be open and the firewall inside your machine in rejecting all the connection may not really matter, because the DDoS attack is about creating a big amount of traffic that is going to surround your machines and make them impossible to serve good traffic to the good customer, not to serve bad traffic to the bad customer. And I just want to remind you that we're talking about public network again. So everything that you reply to a DDoS attack is going to be on your bill, unless you are really fortunate and your internet service provider doesn't charge you for that. But it's always better to understand what are the risks of using this kind of strategy with the geoload balancer. So you would say, okay, my virtual server provider will allow me to create an infrastructure when I can put a firewall in front of it and then all my servers behind, which at the beginning, it sounds like a really good idea, because you do have what is called a parametric firewall. There's a machine in front of it that's managing all the connection that incoming from the internet, and then is managing all the connection in between the two branches of the application. So in this case, I've just designed an infrastructure using our control panel, where the firewall is responsible to receiving communication from the outside, rerouted towards our Nginx servers that is hosting, well, we can imagine a WordPress site. And then the Nginx servers will have to go through the firewall again to ask the database information to visualize the page, and then the database will have to respond through the firewall to the Nginx, and at the end, the Nginx will have to send back a response through the firewall to the customer. Now, what is really happening over here is like, in this scenario, everything seems okay because there are very few machines. But if you start to scale the number of front end or the number of backends, you soon realize that the amount of bandwidth that goes through the firewall, that you funnel through the firewall, is limited by how big the firewall is, by how big the bandwidth of the firewall is. And some virtual provider, cloud provider will limit the bandwidth based on how big the machine is. And what this will create for you is basically underpower your infrastructure. It doesn't matter how many servers you have to serve your customer, your infrastructure will always go at that little specific speed. And again, this is not wrong, and you can do it on our control panel by any means, even if it's not really a cloudy way of doing things. It works. But as I said before, if you're coming into cloud, you come in because you want to adopt something that is different from the architecture and the security point of view. So what I'm going to do now, I'm going to show you with a similar infrastructure to this one, how could be done in cloud in a way to use 100% all the horsepower they are inside the cloud service. In this infrastructure, I created 3 machines like I did before. But you see there's instead of a firewall, there's a Bastion server that's going to help me to log in into the other machines and make sure that I can manage the backend through a management network, basically. I do have my Nginx system, they're hosting my WordPress, and my database system, they're hosting my database. And what I'm going to do now is walk you through how I've secured this infrastructure with basic, simple security that you can do from the control panel of IONOS without sweating it too much. You need to know a little bit on networking, but I'm going to try to go through all the single bits. And please ask a question, because today what we're going to do is just try to clarify what the problems are. So to start with, we're going to start pointing out that every single machine that you see over here is connected in somehow to the internet. You see that the Bastion, the database, and the Nginx, they do all have the green network, a route to get out to the internet. The first one, the Bastion, as you can see, is on the right-hand side. It does have a firewall type ingress, which means that it's blocking all the incoming connection from the outside. But it does have an exception in the center of the page. You can see it says SSH ingress is allowed. That means that everything is blocked. The only port, the only service that this machine is going to be serving to the outside is SSH. And in this kind of firewall configuration, which comes with every single machine and every single network interface inside IONOS control panel, you can even specify your personal IP address, so to restrict it not only to the type of service that this machine makes available on the outside, but even on the IP address is coming from. So I can use this machine as a connecting point to my infrastructure. The rest of the infrastructure is going to be hidden behind the IONOS infrastructure. We don't care, but we do have our own access to get in through our Bastion system. Our database and our Nginx system instead are just going to have an ingress firewall. You will see that there's no exception. There's no exception on firewalls. These are simply blocked. But what is the gain? Why do I need to block all the incoming connection but keep them connected to the internet? Well, when I use this kind of specification, when I block all the incoming connection, what I'm really blocking is the incoming new connection. So someone from the outside, they try to connect directly to my public IP address, to my ports. What I don't want to block is the forwarding or the router effect. So like when you have your router at home, if you ask for a website, an update or an upgrade with your computer, your router will send you a request outside and will let the response to come in and establish related, is called. It will not, and will do exactly the same thing in our case. So blocking all the incoming connection for our DB really means that we're blocking all the requests that we haven't made. In this case, our database and our Nginx machine are going to be able to download updates, upgrades, install new program from the internet, browse the internet without any type of problem. And it solves so many little issues. And if you just adopt this as a way when you're creating your strategy to migrate into cloud, you're gonna have such an easy life. I swear, this is just simple and really effective way to have your machine to keep communicating with the outside. Now let's make sense of all the other connection that you see all around, because there's lots of colors. So let's see. So as we said, our Bastion host is used to connect to the background through this brown network over here. And we can call it, if you want, a management network, because once that we log in through our public network via SSH on our Bastion, then we can log in into a database, we log in into our Nginx, and Nginx can connect back to the database if we want to. All of this to manage our machines, to make sure that all the systems are up to date, the security patches are installed correctly, then we need to deploy new code or we need to make a change on the database. We do have then the Violet connection where Nginx talks directly with the database, this one over here. And this is not just a private connection, but this is just a dedicated connection between the two. So Nginx and the database can use the full power of a network interface to talk to each other, to exchange the data without going through any gateway, any firewall, any point of access. And if you want to tighten security between the two, making sure that Nginx talks only with the database on a specific port, you can do it exactly the same way that we build the firewall for the Bastion host. You can create exception for the database. You can create rule for the database and the Nginx server. And then we do have our orange arrow that goes from public to our network load balancer to our Nginx. And This is without a firewall. We do have a network load balancer that is exposing our Nginx server. So where is the security over here? Well, if you go on our infrastructure and you click on the network load balancer, you will see that every time that we want to create a connection to make available something on the outside, on the public, we do have to specify a listener, so a specific port, and we need to specify a target that's going to be contacted by the load balancer only on that specific port. So in some respect, it's not a firewall per se. It doesn't have all the capability of a firewall, but what it does, it just filters all the requests that are coming in, and it just get one single port out of it, and that forwards the request to the Nginx and wait for the Nginx to respond. So what really is the takeaway of today? What really is the message they wanna send out for you about security in cloud? Is that when you normally build a dedicated virtual server, your internet connection on a single network card is protected by the firewall that sits inside your dedicated virtual server. And from that point of view, you're still vulnerable to lots of attacks that can get into your system, because your virtual and dedicated servers will have to deal in terms of CPU or memory or disk and bandwidth with this type of attack. When you instead come into a cloud service with IONOS, DDoS protection, firewall are outside, and they're protecting your cloud service from the infrastructure point of view. So because of the way that we automate our system, every time that your machine comes up and comes online is automatically protected by the firewall if you're setting it up correctly, and by our DDoS protection system, which you don't even know that is there, it's just there. So the other thing that we do, if this is a little bit overwhelming, just get in touch with us. We do have a fantastic program where we let you try our control panel, where we let you try our cloud. And before you can even start trying with our clouds, you will speak with someone on the solution architect team, and we will discuss with you what is the best solution for your infrastructure. We will discuss with you what is the best way of transitioning your infrastructure, your security into cloud. That said, I'll leave the space for you to ask questions, and I hope there is some. I hope to have tickled you a little bit to ask a couple of questions. Thank you for listening. Okay, so thank you for the first question. So the question is, how do you charge for the firewall, by rule number or traffic? So the firewall is a service that sits outside your cloud server, but it's completely for free. You can add, so a firewall is going to be added to every single firewall function is going to be added to every single network card that you add to your cloud server. You can have a maximum of 20 connected devices between hard drives and network cards. So let's say that you have one big hard drive, you can have up to 19 network cards, and the firewall is enabled by default on every single one of them and is absolutely free of charge. Also, you can configure the firewall through our automation system. So you can configure it through infrastructure as a code with Terraform or through the API directly. So yeah, there's no reason why not to use it. Okay, next question is, how can I activate the DDoS protection? There is no need to activate the DDoS protection. It is enabled by default. It is something that is protecting our entire network all the time. It is the baseline of our service. So when we see some potential malicious attack that coming our way into one of our customers' public IP addresses, we automatically tend to verify, and then if it's a bad actor that's trying to create traffic for DDoS purpose, we automatically cut it off, basically. And the good thing about DDoS protection is that we keep you online. Lots of other internet service provider would just close down the IP address, so nobody will be able to reach your address. With us, because of the DDoS protection, when the DDoS protection kicks in, you're gonna be able to still serving your traffic to your customers. There's another question. Do you have any additional service to help me secure my infrastructure? Well, we do have a lot of service. I mean, starting from the DDoS protection is baseline level. There is another level of DDoS protection where you do have support that's not for free, but it's really useful. For example, if you can identify attack, you can speak with someone on the DDoS side, and they can help you not only isolate the attack and reducing the effect of the attack, but can also help you to understand what is the root cause analysis they're gonna do with your root cause analysis, and they're gonna help you prevent new attacks. There's also the solution architect team that is gonna be able to help you with you can schedule a review with them to see when your infrastructure grows or if you have problem. We are always there to help you out. We never let you down. And we also do have best practice that we follow all the time. So when you're starting an infrastructure with us, just book a meeting with us. It's going to be the first meeting. We're going to help you define what your infrastructure should look like. And from there, you can try to build it on your own, or we suggest one of the partners that work with us that can help you build the infrastructure. But from there, we do not disappear. We're still there. You can still asking questions. We are still available to respond to all your questions and help you to get up to speed with your infrastructure. Obviously, we want you to be successful, right? So we're going to do everything that is in our power to do that. Okay, there's no more question. No, nothing more is coming in. That's absolutely fine. Thank you everybody for listening to this second episode of our series, and stay tuned for the third episode where we're going to discuss about backup and disaster recovery and how to set up a backup agent and make sure that your infrastructure is protected. Thank you again, and thank you for listening.